introduce the speaker of today. The speaker is my colleague and our product manager of our ArcFlash protection products. Well, some have also called him a real rock star of ArcFlash protection, Mikko Manninen. He's sitting here next to me. And his topics today include the following. He will start by talking about what's new in AQ100 series. Then he will address Rogowski sensor support that we now have in our portfolio and how that impacts retrofitting of existing switchgear. Then he will talk about integrating ArcFlash protection system into your overall protection and control system so that you can also visualize ArcFlash protection data in the SCADA DCS system. Designing the system with help of our standard ARC schemes will guarantee you validated operation, and that Mikko will talk about too. And finally, he will address a real-world case. It's an arc quenching case, and this will take us to the US and to Waupaca foundry plant, where they had an arc event, and their arc quenching changed everything. So with this, Mikko, the stage is yours.
Thank you, Maarit. Hello there. Welcome to the webinar also from my side. First, I show you a little bit. There are many reasons why we do what we do, and during the years we have done several testings in different laboratories all over the world, and we have found, and probably many others have found, that testing of the systems and applications is a key factor in studying, understanding, and teaching what we have learned. And of course, it's fun. So here I have two very short videos from the testing before we keep on going further the presentation. This one, according IEC 61641 technical requirements standard, which provides guidance on testing low voltage switchgear and control gear assemblies under arcing conditions due to internal faults, focusing on safety and performance. So 61641, it is a standard which in this test we are proving any switchgear manufacturer, any panel builder, we are proving that the construction and enclosure is safe for workers who are standing in front of the panels. And in this case, all the ArcFlash pressure, most of the ArcFlash pressure, and everything from the ArcFlash which shouldn't explode to the front goes to the back, at the back of the panel and downward. So this is one example from 61641 testing. The next one is then filmed from front, and this is another standard, or this is actually a 2020 released IEC technical specification 63107, which states that it is requirements for integration and testing of arc quenching devices or internal arc mitigation systems in low voltage switchgears and control gear assemblies, if I remember right. Yeah. So we did this in many ways, and we also performed this with a quite unique way. So we wanted to test this also. We wanted to go beyond the standards and we performed this testing also doors open. And this is if we think about global perspective, many countries where I visit, for example, everybody says that we never work doors open, but it is the real thing is actually, and the true story is actually that in every country there are situations that people may need to work. They may need to open the enclosure, open the door, maybe test some voltages. And in some countries, you are able to do testing with live voltages if you just write and report with the correct papers. So this is a IEC TS 63107 testing doors open, and this particular test here is 65 kiloamperes, 730 volts, and this is with arc mitigation system. I can actually draw here something that the arc is ignited here. Remember, 65 kiloamperes. We have some point sensors here in this panel, quite few. And arc flash relay, which is here, is measuring the current, and it's also detecting the light from the arc ignition. Its main purpose is to trip fast, and that is always the main purpose for arc flash relay. So you can detect, you can protect, and you can mitigate. So sensor is for detecting, and also different current monitoring ways are also detecting. But when you want to protect, and of course, I always want to protect, then you need a fully functional circuit breaker and correct wiring and so on. So we are tripping the breaker, but simultaneously we are also sending a coded fiber optic message to this device here. This is called arc quenching device, and it is a device which can be reactivated. And you can focus on these points where the arc is ignited and where the arc quenching is operating. So I will play the video now. It will probably play a few times because it's quite fast. So you can see the activation and reaction here. So let's go with this. Yeah, okay. So now we can remember the previous slide and the arc flash explosion, we can say, and compare it to this one. And we can see quite significant difference. And in this case, we did not lose any of the copper at all. So everything is fully okay to use as many times in laboratory again. So we still have this panel for the next testing. So this is always good. Okay, let's carry on to today's topic and start with what's new. For a brief introduction, for those who may not be familiar with our products, Arcteq provides a comprehensive range of arc protection devices, sensors, and arc quenching devices which can be reactivated for both low voltage and medium voltage systems and applications. So low voltage and medium voltage systems and applications. I won't go into great detail about each product, as you may already be familiar with the products. But instead, I will focus on what's new in AQ100 arc protection platform. And remember, during the presentation, remember the Q&A. Use your voice and ask questions, and we will have a answering session when we are at the closer to the end of the presentation. So carry on. First, I will introduce the Rogowski coil support as an alternative method for measuring, monitoring, and detecting high currents during the arc flash, high currents during the arc flash. So conventional CTs, conventional current transformers, they don't disappear to anywhere. It is still always available here and with the products, but this is an alternative method. And I will explain it a bit further when we carry on. As you may already know, the standard approach to activate arc protection involves mainly two criteria, current and light. There are other ways also, but these are kind of most common ways to protect with two criteria. Why two criteria? It is mainly to avoid nuisance tripping. If we have a one criteria only, which is still used in many locations worldwide, if it's only one criteria, there is a slight risk that one criteria is more sensitive to trip something. So a little bit background here. Yeah, Rogowski sensor in this slide here. This is an example of the low voltage Rogowski sensor, Rogowski coil. Both names can be found. So we need one of these for each three phases, and can be connected to this terminal block here. All the settings are in always with AQ100 series. It's very easy approach and simple. So practically you set up these dip switches according to design. And when you are done with that, you can press this one button here and auto configure everything. So this is a well-respected way of working with these arc protection systems. No computers needed if you do standard systems. And like the current transformer versions, also this one accommodates maximum 12 point sensors, which are connected here in this terminal block. Let's move on. About Rogowski sensors and the units. AQ110 device, I call it, and many so-called main unit, supports three different secondary coil options and millivolts options. So how Rogowski works, it measures the current and the output is millivolts. So it can be selected in the relay. It can be selected to 22.5 millivolts per 1 kiloampere, 100 millivolts, or 333 millivolts per 1 kiloampere. And these options are available for all main units, including both the point sensor units and the fiber optic versions in low voltage and medium voltage solutions. And a couple slides back, you saw the LV version Rogowski sensor, and this is an example from the medium voltage sensor. So this particular one is working with the 100 millivolt per 1 kiloampere when it is 50 hertz. So it fits very ideally with the medium voltage relay version. Secondly, I would like to introduce the Modbus option. Similar to Rogowski, this option is also available with all main units, AQ110, as well as with the point light sensor units, AQ103. In both low voltage and medium voltage versions, so low voltage and medium voltage, point sensors and fiber sensors, and the main unit and this AQ103 light sensor unit. The Modbus option is based on Modbus RTU over RS485 communication. And this feature will open up a whole new range of applications, which I will explain in more detail later. At the back of the relay, let me draw here something. So here, hope you can see this here. So these two on top here, these are actually the point sensor units, and the Modbus option is you can follow the red arrows here. So you can find the Modbus terminal, and then the fiber optic units, you can find it from here and here. And what is different in these units is that the left one here, this is the standard CT version here, and this one is Rogowski version here. Because we have these new functionalities, these additions, the main unit order codes have been updated from 4-letter to 5-letter formats. So if the last letter is A, then it's exactly the same like it was before. If the last letter is A, it is with the CT inputs like it used to be always. If the last letter is something else, B, C, or D, you will then get either Modbus functionality or Rogowski inputs or Rogowski with Modbus, like for example with the code D. Here. So all in all, if we quickly calculate all of these, we have 12 new options, depending if we have low voltage or medium voltage, if we have current monitoring with Rogowski or current transformers, or if we have Modbus or no Modbus. So 12 different new options. Then I talk a lot about retrofit installations, and this is actually where I started my this profession more than 20 years ago. It was only 100% retrofit. Absolutely, old power plants who experienced dramatical arc flashes. These old plants and old switchboards were all retrofitted with arc flash protection systems. And I believe, and I know that I share this opinion with many, that well-maintained switchgears can be used for years and years longer with proper maintenance. For example, circuit breakers. With the protection, like I mentioned before, we have detection, protection, and mitigation. So proper protection, you need to have well-maintained circuit breaker. You need to have a well-tested and maintained circuit breaker. That is absolutely one of the main things of the protection. All the other circuits as well. So either is it the Rogowski or is it the current transformer, it has to be tested and proven. And well, adding these retrofit installations and adding these safety functionalities, safety products into the older switchgears, it is also very sustainable way. So maybe 10, maybe 20 extra years for panels. Who know what happens? But it is a very good way to add safety. And then over here you can see this is an example of the CT current transformer installation here. And then Rogowski installation is here. This is just a picture to illustrate the difference. This is something what you are most probably very familiar with, and I don't go that much detail, but installation of the sensors are significantly easy, very easy actually. It is a matter of minutes instead of hours. And many times in installations, scheduled time for the outage can be very limited. I have been doing a lot of retrofit installations where they gave us 8 hours per day, and doing all the paperwork took 4, because you need to do the paperwork when you get the board for the job and when you return it. So from 8 hours window, you have 4 hours to do the job. And it is something you can, maybe you have faced the same thing in your installations, but this is very typical if the plant or if the site is something critical. Very many times there has been projects that they absolutely need arc protection and arc mitigation systems to make it safer, because there are some substation and some electrical rooms that no people wants to open those doors. They know it's not safe, and they absolutely want to have extra safety there. However, if they can give you 4 hours, if they can sometimes give you 8 hours, it can be a big challenge, and it has to be planned well. And of course, this quick installation of this Rogowski coil, it's a huge benefit. So you can go to the site, you can pre-plan all the sensor mounting, you can pre-plan where to mount the relays, you can have a good enough team to work with that, and then installing the sensor is also done in minutes, so it helps. And I know cases that the ArcFlash retrofit projects have been postponed because current transformers need maybe an extra panel because they don't fit into the existing coppers, and they have been even built an extra panel and extra bus bars only for that purpose. So that is many times actually a bigger job than the actual ArcFlash sensor installation, which is fairly simple. Like current transformers, Rogowski coils also have an accuracy class and error tolerances, which doesn't play any critical role within arc flash protection. So we know that there is some tolerances that is fine. The tolerances are very narrow and small, but we know it, but it doesn't really have any impact or in arc flash protection. And this is absolutely one of the best thing with the Rogowski coils. They can easily handle an arc flash currents in every application. So for example, this low voltage version, the blue one, if you remember from previous slides, it can go up to 300 kiloamperes, which is quite amazing. So up to 300 kiloamperes without any saturation. Rogowski is also, it is a frequency dependent. So it has a 50 Hertz and 60 Hertz, it has a slight difference. So 50 Hertz, if we are 100 millivolts, then if we are in 100 millivolts with 50 Hertz, we are 120 millivolts with 60 Hertz. And don't worry, you can use the same in 60 Hertz countries and 50 Hertz countries. You can use the same equipment without any hesitation. And then there's a drawing here on the right side here. Let me explain this a little bit. So also this is the retrofit part, because I just like to talk about it. So imagine that you have an older board, maybe some minimum oil breakers or from that time, or it doesn't really matter. It can be actually even new board, but the protection settings are with the longer delays, or circuit breaker takes a bit more time. So this is just an example about the arc incident energy as a very much simplified calculation. So this y-axis, not that straight line here, but you get the point. So the y-axis here is the magnitude of the fault. Magnitude of the fault, how much we have short circuit current and arc flash current to the fault. And the x-axis here, this is even worse. X-axis here is the duration of the fault. And this area here is then the arc flash incident energy. And with the arc flash protection, we can then limit it to here, which is already a lot better comparing to this red one. And with arc quenching and arc mitigation systems, we can go to here. And this is very self-explanatory here, that we can have then even 20 times less, or even much more if we compare this whole area. So even 50 times lower values. And this all according standards and all these calculation standards, this all has a huge impact and effect. What to wear on site, what kind of PPE, what categories we are in, and so on. Also, retrofitting the sensors are much easier now. Here are some pictures, photos of the sensor installation. It's the same color here, but here is one sensor in the circuit breaker compartment or the bus duct compartment, and then many sensors here and here and one here. So this is a retrofit installation. Both of them are from the same site. It is a retrofit installation, and then the bracket here is built for the easier retrofitting and easier testing and installation of the sensors. So you can drill this bracket inside the panel board or switchgear, and then just push that sensor on top of that bracket. And if you need to test it, or if you need to turn it another way around, you can just remove it and change it and put it back. Very easy to use. Then integrating this Modbus to the SCADA, DACS, any control or automation system. Well, let me tell you. Yes, the most common approach has been and is to utilize the AQ250 series alarm annunciator, like this one here, or any other AQ250 series relays as a Modbus master. So this is the master who asks questions from these ArcFlash relays. And this AQ250 here also serves as a protocol gateway to connect with other systems seamlessly. For example, if you get Modbus RTU here, you can talk to the SCADA with some other protocol. In this example, for example, 61850. And I may have some more example pictures about using this in real life. And let me go a little bit further. Here is actually in the next slide. So here you can see a couple of examples of how the system has been used. This one here is from the substation, 110 kilovolt substation. And it is a single line drawing scanned from the PDF, and then it's just installed or put it. It just has been configured inside the relay. This is very easy. It is actually very flexible display, and this is one of the best part of using this kind of display and this kind of alarm annunciator or relay is that you can actually know what occurred and when and where. So did you have ArcFlash in this cable? And this sensor is showing it to you. Especially when you have arc quenching device in use. As course, this arc incident energy is directly related to the time and duration. And if the duration is like 4 milliseconds, sometimes it can be a bit difficult to pinpoint where the fault occurred. And if we add 20 times more energy, 20 times, if we add that time duration, then you can see other visibility, not on the relay display, but you can see it from the door or somewhere else. And then this is a dark theme, this one, and this is then light theme here. Also very nice application here. This is a low voltage, this is a medium voltage. Photos were taken by me, not very best quality, but I know ArcFlash, but I don't know always camera flash. But you get the point. Hope you get the idea here. All of these must fulfill the standards. This is how I want to say it. In some countries and in this big world, we don't always need to follow the standards in every country. Somebody may say that, but you need to obey the law, and the law may demand to use the standards, which is the most typical way in countries. So I just put it this way that all of this installation, any installation, is it Rogowski, is it CT, is it ArcFlash, is it sensor, is it arc quenching device, must fulfill the standards which are built for those. And on this slide, you can find few screenshots of the latest standards. I want to just spend some short time with this, that you know what is happening global level with the standards. So, for example, 2018 IEEE 1584, 16 years of development and a lot of ArcFlash testing. Then 2019 AQD standard, 2020 integration standard, and so on. And then giving an idea from this time frame or time, this is 30 years time frame. And only one thing I want to show with this slide is that if you see the pace of last years, and starting from 1995, there was like a 10 years gap before the next standard. And then if you see the last few years, you can see that something happens every year only related to ArcFlash, which is good. Yep. Let's move forward. Let's have a look at these standard application schemes. Standard applications offer the simplest method for arc protection projects. Warmly recommended. Across the globe, many electrical networks share a lot of similarities. For instance, the main tie main configuration, main tie main, and so on. Main tie main configuration is probably the most commonly found various continents and offshore installations. And you can find from the standard applications, you can find a very much simplified models like this one. This is for the main tie main low voltage application. You can find the simplified model to quickly identify if this is anyhow useful in your case, in your system. And when you see that yeah, I want to use this case, this is exactly what I'm looking for. So then you can find even more detailed diagrams with the trip matrix, with the dip switch settings, with the wiring diagrams, and pretty much everything. And this is then easy to adapt and configure absolutely in your case and system. Then, yeah, shortly about the SAS, but then I move on to this case study. So what we promised earlier on. So we have many case studies during the years, but this one is quite recent, and it is a medium voltage quencher activation. So it is also very interesting. So a few words about this customer and this plant. So it's a critical power heavy industry plant. 10 40-ton induction furnaces in Waupaca, Wisconsin, USA, and they melt nearly 2 million metric tons of iron each year. And 2023, they made a huge upgrade with the safety, and it was a massive retrofit installation and also new build on same plant with the full setup of ArcFlash protection, ArcFlash detection, protection, and mitigation system in their medium voltage distribution. And the main idea with this PPE, main idea this arc quenching device and mitigation system was to also have a safer categories for the personal protective equipment. In this case, from category 4 to category 1. what happened? There's a lot of text in these slides, but main key things. They lost all power. Not good, or it's horrible. Restoring power in 59 minutes, which is fantastic. So these two things. Losing power is not good, and getting it back, it's great. We studied all the graphs, oscillographs, with our system, and we found out that there has been arc flash from face to ground, and we went through with the team over there, and they started to study, and they started to search this possible fault location better, and they found it, which is good. But here you can see that when arc quenching device activates, in this case, it is not much you can see outside the board, from outside the board. So it might be sometimes tricky to pinpoint where the fault occurred. And I believe it was same thing here, that it was quenched, and then nothing was seen outside. So they had to look again, and they found it, and they seems to be very happy, because from this slide, also a lot of text, but the last text is always very happy to read, that thanks again for all your help. So this is always good to smile, and good to make people smile if possible. Then they changed the cable, and plant was restored to normal operation. So there is always a cost. Even changing the cable is cost, but definitely they are happy to do it this way, if you compare it to losing the plant, for example. So very good. This changed everything. Then I think time to move to questions, Q&A.
Yes, you think absolutely correctly. So thank you, Mikko, for your presentation, first of all. And yes, now we have about 15 minutes for Q&A and for closing the webinar. In the Q&A, you can still post more questions if you would like to. So I will start from the first one and move up to the later ones. So yeah, please feel free to send additional questions as we go. So Mikko, are you ready?
I hope.
Good. So the first question is about the Rogowski coil support, and the question is if we still need light plus current for tripping arc quenching device if we have a Rogowski coil.
Yes, that is the recommended. That is the recommended way to trip the arc quenching device. Usually, there are cases that, for example, light only methods can be used to trip the breakers, but arc quenching is something that we recommend to keep with the double criteria always.
Excellent. Next question is about the advantages of using Rogowski coil instead of conventional CTs for current detection. Maybe you can still summarize. I think you addressed this already in the presentation, but maybe you can make a quick recap of the main benefits or advantages.
Yeah, installation time. Installation time is very good advantage. No saturation. So sometimes I have seen arc protection built even with the metering CTs, and I have seen also broken metering CTs after quite many They are typically in a laboratory test, but the saturation, this short circuit current doesn't fit in the iron core. And if you do it multiple times, it is a very big damage. Protection CTs are capable to handle that, but the Rogowski coils then don't have any issue on saturation because it doesn't have this core issue. So that is very good. Quick installation, no saturation, very good for retrofits. Yeah. Also, I think it might be very attractive sometimes what comes to the cost. So I think these are very good benefits.
All right, that was a very good summary. Next one is about the arc quenching device retrofit. So how does the retrofit work of arc quenching device in an existing panel? Usually a separate vertical section is needed, right?
Not always. If you can find a good location, the recommendation is to install arc quenching device as close to the main breaker as possible. And in some cases, it is not always possible. There are some certain rules, but there has been even extra, let's say, extra enclosures like boxes outside of the panel. So, and in some cases, even on top of the roof of the panel. So it is a case-by-case designing pretty much always. And then some panels may have some extra room. In low voltage, the AQD arc quenching device size is about half of the height of the main breaker. If we consider, for example, 3200 amps breaker or 2500, and you take about half of the height, that is about the physical size. Then when we go to medium voltage quenching devices, depending on the voltage level, it is less than 60 centimeter wide in 17.5 kilovolts and 74 centimeter wide if we go to up to 24 kilovolts. So it's very flexible. They can be mounted vertically and they can be mounted horizontally or vertically, both ways. So somehow we have always found a good location, and there is always a way.
Excellent. Then next question is about the testing according to standards. So the question is, AQ100 has already been tested according to IEC 60947-9-2, and whether we have CE declaration available on the web.
Yeah, it has been tested with all of the latest standards. How to say 63107, 9192, and they are all part of. We actually have done the testing with the several panel builders and also ourselves. So some documentation can be found then from us, and some documentation are not to share, unfortunately. But we can always find a way to support you.
Very good. Then we have one more question at the moment, but we still have time. So if you have any question in your mind, so please feel free to post. So then the final question for the time being is, as long as Rogowski depend on frequency, are these affected by higher harmonics?
Yes and no. The harmonics is it can be also bad for current transformers and also for the Rogowskis. But the harmonics mainly is filtered out inside the relay. what signal we get in, it is kind of filtered inside the relay. But I would say that yes and no. I always take every harmonics very seriously, and that's why we filtered EMC and EFD and harmonics within the relay.
All right. If no more questions, so then thank you for everybody for the questions. And before we close, so Mikko, now you can bring up the slide that you wanted to show earlier.
This one.
This one, yes, exactly. So a couple of tips for you attending the webinar today. In case you would like to investigate AQ100 series further, we have this QR code on the left-hand side, so please feel free to scan it now. If you would like to get access to the latest AQ100 series product catalog, this is also available on our website, but this is a shortcut for you if you would like to take a look. On the right-hand side, we would like to mention also that we have recently released an Arcteq product configurator, helpful tool available via our website. And this tool can help you to find the right product for your application, and you can filter out till you find products that suit for your application. After that, you can configure the hardware and instantly generate complete order codes. So that makes the ordering very easy. And as a result, you can also download a tailored datasheet that contains only your specific configuration details, no extras, just what you were asking and what you were interested in. And to finalize the process, you can also directly send a request for quotation to us from your configuration, from this same product configurator. So please feel free to explore and let us know what you think about the configurator. So then we can take the final slide there. Next one, please.
Yeah,
Mikko,
I quickly go back to Q&A. That
sure.
Of course we are available for Q&A after this webinar as well. So feel free to contact us.
Yes.
And then next one.
Yes, but actually we got one more question here in meanwhile. So let's take that before we take the next one. So Rogowski around cables also extends current detection zone to include incoming cable terminations within current zone. Yes.
The installation location of the Rogowski, that is a good point. If I understand correctly the question, so Rogowski is actually very much easier to install to larger zones, or even typically current transformers are always after the cable termination or bus duct termination. And then Rogowskis are a bit more flexible, that we have like 4 to 6 meters of cable from Rogowski, and they are very flexible to even include that cable connection zone, and which is not typically used in our protection. Was that the question, if I understood correctly?
Not sure. Maybe is it asking about the extending the area where you can actually now cover?
Yeah, this is kind of, So if you just install Rogowski, maybe a little bit further and before the cable termination, then you can also cover that with double criteria.
Good. And there is one more question here also. How many operations under fault? Maybe referring to quenching device, I believe.
Yeah, in low voltage, we are about to change that very, very soon. So we have always kind of limited that to 2, as we expect that to be the worst case scenario, 100 kiloamps, and that has been tested now quite many times. So last test was exactly a year ago, and we tested 19 times, and the last 7 was 100 kiloamps. So you will see very soon a small upgrade on that. But if the 2 times has already been used, then it's always possible to contact our technical support, and we can upload more charges to the system. So depending of the fault current what was available. And medium voltage 1.5 operation, 50 kiloamperes 3 seconds. Yeah, 50 kiloamperes 3 second 5 operation. And both systems can be also tested. This is actually good point because there are new standards also, and standards and rules, which I didn't mention earlier, but that there are new standards and rules that in some countries these kind of equipments must be able to test and prove and witness and report. So it is also very good this to get that opportunity to actually test and prove.
Good timing, Mikko, with your comment, because we just received a question. How can you test that AQD is still in good condition after a trip?
How can we test it? We have tested that in our own testing with a very harsh environment and a very like how to say we have kind of over tested that we can guarantee the operations under arcing conditions. So this is where we are actually after this 19 test with the very harsh environment and pretty much everything you can imagine. Phase to ground, between 2 phase, 3 phase, 15 kiloamps, 30 kiloamps, 65 kiloamps, 100 kiloamps, and like 7 last time. And after opening that device, it still looks something that you can use it again. So it kind of looks like still like new. So we are confident of the functionality in any arcing conditions. One thing for sure is that always when you quench, you need to trip something also. So you need to trip the main breaker, upstream breaker, tie breaker, whatever is feeding the fault. Then you need to trip that all fault surrounding breakers simultaneously. So that is of course one of the main things.
The person who was asking about this was curious to know how this works on site. So how can you test on site after an arc flash event? So can you test it?
After an arc flash event, and minimum every 5 years, I recommend, and it is kind of a thumb rule to test the equipment anyway, that the mechanism is moving, and then you can also measure the bus bar impedance that it goes to 0. Of course, all this testing has to be done in a proper way and in safe condition within all safety rules. So testing when it's open that impedance is high, and when it's closed that the impedance is low. Then that is the mechanical testing and proving.
All right, so we get more and more questions here.
Good.
That's very good, and we still have time, so no worries. So aside from being able to prove the system under maintenance with no current, is there any other maintenance to do?
Let me hear that again.
So aside from being able to prove the system under maintenance with no current, is there any other maintenance to do?
Yeah, for the quenching or for the full system. Well, only maintenance what we recommend is actually to do the testing every 5 years, or if there is some site rules, for example, or if there's some site interval to do testing, for example, every other equipment, for example, breakers every 3 years or every 4 years, then that is of course the best time to test also arc flash protection systems and quenching device. So other maintenance, not really. The most important thing to arc protection, it is always a detection. It detects the light, but to keep it, to make it protection, you need to be able to trip something, and you need to prove that trip is working. You may need to retest current transformers or inject the millivolts to the system to prove the Rogowskis, and to check the wirings, keep the wirings and everything well organized and tested. So that is kind of the maintenance. Every 5 years is very typical maintenance. Otherwise, it is good to go further on without any maintenance.
All right, I don't see any other new questions, so maybe that was all the questions, so we can move on to the next slide. So, in case you have been wondering, this logo and number 15 on it. So this is because this has been our 15th anniversary year. And during these 15 years, the company has developed an impressive product portfolio and introduced also a number of innovations, like, for example, the arc quenching devices that changed everything that Mikko was talking about. So we would like to thank all of you who have been part of this journey during these first 15 years, and those here attending our webinar today that are new. Welcome to the journey. We are happy to have you with us. So far we have received, let's say, more than 2 questions, but from in 2 different posts. So let's start with the first one, which is an interesting one. Is it mandatory to use Arcteq AQ100 series relays to activate the AQ1000 arc quenching device, or can other protection relays from other makers be used to initiate it?
Okay, well, it is a good question, and I can promise you are not the first one. Some installation and cases have been directly. Some other relay cannot talk to arc quenching device. That is a fact. It is a coded signaling, but there are some cases where kind of a hybrid technologies has been used. So not directly, which is no, and case by case can be considered.
All right, thank you, Mikko. And the next one contains kind of 2 questions, so I'll split it to 2. So the first part is, do draft EN 50110 and IEC working group documents provide any guidelines or recommendations for total clearing time, detection plus quenching? For example, do they suggest a target like 6 milliseconds or less?
Yeah, okay, this is a working group. I think this is a working group 19 or something. Yeah, I don't know exact details. That detail about 6 milliseconds or less. I hope it would suggest a target like that. I have seen in some other documents target time 5 milliseconds. For example, in some certification test, like proving test has been typically used to 5 milliseconds. And then there are another standard called, if I remember right, 60364. That's 42 or something that way, which a kind of guides to use arc quenching system always in certain installations, and those are divided to different groups. Like I think it was more like this is a little bit out of my memory, but like nuclear, oil and gas, that type of critical environment. So this is something to look into. But this 501110 is something I'm also studying and trying to set myself.
All right. So then the second part of this question here from Hamid is, do any other standards such as NFPA 70E, IEEE C37.20.7, other North American standards give similar guidance on clearing time for active arc flash mitigation systems?
Yeah, not in that level. There are certain standards for arc mitigation systems, how they work and operate and how they should operate, what is the maximum voltage drop and so on. But NFPA 70 gives an alternative method for calculations, like IEEE 1584 is another alternative method of calculating the energies. Most important thing, I think, everywhere in the world is probably every site should perform risk assessment. I think that is always a good approach. That what is if the risk assessment has been done, how do you know the risk if you don't know what kind of energy you have inside that particular switch room, for example? So this is probably something to approach. But they all mention something, but not clear thing that it has to be exactly like 6 milliseconds. It's more like that you can calculate, for example, in ETAP calculation software and others similar softwares, you typically use a fixed value, fixed millisecond value when arc quenching system has been implemented.